Hey guys, Mr. D here with another video from Chapter 5. Today we're going to be talking about the third and final method of solving systems of linear equations. Okay, so the past few days we've been talking about graphing and substitution. Okay, those are two different but very effective ways of solving systems of equations, but now we're actually going to go into one final one, which would be solving by elimination. Okay, and they each have their benefits, guys. So that's the reason why we tend to show people all three of them, because sometimes it's just much easier to graph them. If, for example, you have something like this first example that I have here, where you already have two equations that are in slope-intercept form. Okay, so that might be one of the reasons you would want to graph right away. All right, if you have something like number 2, where you have, I'm sorry, not number 2, but example number 2 here for the substitution column, you already have one of those variables equal to something else, okay? Like y equals all of negative x plus 1. That's when you would go ahead and use substitution, okay? And then we're going to go ahead into one more different type of problem, which is actually solving systems by elimination, and that one involves a little bit more in-depth stuff. But for now, let's go ahead and review a little bit on graphing and substitution. And just for the sake of time, and because I know we have already done these exact problems in the past section, I'm going to go ahead and fly through these pretty quickly. So here for the first equation, I'm going to go ahead and graph that. So I have a slope of negative 1 over 1 and a y-intercept of 0, comma 1. So I'm going to go ahead and start graphing. So down 1, right 1, down 1, right 1, down 1, right 1, down 1, right. Okay, pretty simple. Like I said, I'm gonna try to fly through this just to make sure that we can start looking at elimination right away. Okay, so this would look something like that. Okay, and then this bottom equation is also in slope-intercept form, which has a slope of 1/4 and a y-intercept of 0, comma 4. Okay, so I'm going to go ahead and start there. I'm sorry, 0, comma negative 4. So I'm going to start there. I'm going to go up 1 to the right 4, up 1 to the right 4, or down 1 to the left 4, down 1 to the left 4. And as you guys can already see, there is a point of intersection, which is actually right here. Okay, even though my graph doesn't look like there is, that actually would be the point of intersection if I were to graph these straight. Okay, so that is my point of intersection. I'm going to go ahead and write that down. Is there a slot here for me to write that? Yes, there is. That would be 4, comma negative 3. Again, just like the problem we did in the example in the previous section. This one we also did when we did substitution. So once again, we always check to see which one of those two equations already has one of the variables solved for it. It looks like this one does, because y is equal to all of that negative x plus 1. So I don't see why I couldn't just put that in there. So that's exactly what we did here in our example. Okay, so I have x minus 4 parentheses negative x plus 1 equals 16. Now I just have to finish it by distributing. So I get x plus 4x minus 4 equals 16. Those two are like terms, so I get 5x minus 4 at 4. So I get 5x equals 20 divided by 5, and let me scroll down. I get x equals 4, similar to what we got for graphing. So I get a 4 here. I'd have to find my y now. Again, take any of your original equations. I'm going to go ahead and take that top one, which was y equals negative x plus 1. But now I'm going to substitute in that 4, which is just negative 4 plus 1, or in other words, y equals negative 3. Notice again, these two right here are the same answers, and the reason why is because they're actually the same system. They're the same set of linear equations. Okay, they just might look a little different because they're written a little bit different. Okay, now we can move on to elimination. We're going to see that if these are in fact the same equations, then we should end up with a similar answer. Okay, so let's make sure we understand these types of problems real quick. So if you notice on the first equation, we have x plus y equals 1, and then in the bottom one, we have x minus 4y equals 16. Okay, just like in substitution, it would be kind of nice if we can do something to where we only have one variable, okay? And what we're going to try to do is get only one variable, either all the x's or just all the y's, by eliminating and manipulating one of these equations in order to get them all to be just y's or just x's. Okay, that sounds a little tricky, guys, but again, with practice, we'll understand exactly what that means. So, by looking at both of those equations, so let me just make sure you guys are on the same page with me. By looking at this one and this one, let's look at both of our x's and then both of our y's. Well, the x's actually the x's are exactly the same. Okay, what coefficient would be in front of the x? Well, in this one there would be a 1, and in this one there would be a 1. So if I were to add those, that would actually be 2x. So it doesn't eliminate my x's. Okay, what about if I add the 1y and the negative 4y? Well, that would give me negative 3y, so that wouldn't eliminate them. So we have to manipulate this somehow in order for the x's or the y's to drop out. And as you can see right here, what we're going to do is multiply the top equation by negative 1. Okay, so if I were to do that, if I were to multiply this by negative 1, okay, and if I multiply all three terms by that, this is what I would get right here. Negative x minus y plus equals, negative 1. Okay, now notice if I were to try to add them, so I'm talking about adding the columns now. So if I add these two, if I add these two, and then if I add these two, okay, so what would I get now? I would get negative x plus x. Well, those would actually cancel each other out. Then I would get negative 1y minus 4y, or plus a negative 4y. That would give me a negative 5y. And then negative 1 plus 16 would give me a positive 15. Notice I only have a y now. I get negative 5y equals 15. I can now divide by that negative 5, as you guys can see right there, in order to get the y all by itself. So we get y equals negative 3. So yet again, our solution has a y of negative 3. And just like before and how we did with substitution, if I have one of the variables, I can now substitute it back into the equation, which is exactly what I'm doing on this step here. Okay, I substituted, whoops, that looks completely black. You can't even tell what that is. Okay, let's do it this way. So I'm substituting it back into that equation, and I'm putting my y in there. Okay, so now I get x plus 12 equals 16. Subtract the 12, you get x equals 4, which is what I needed. So my final answer is 4 comma negative 3. So yet again, these two are similar as well. Okay, all three of these answers are the same. The reason why is because they are actually the exact same equations that make up the system. They're just written a little bit differently. Okay, so let's go ahead and continue on with elimination now. So these are the types of questions we're going to ask ourselves, kind of like what we asked ourselves when we were doing substitution. You have to ask yourself, which variable is easiest to eliminate? Notice up here, I noticed that both x's were almost exactly the same. Actually, they were the same. They were both positive x's. But if I could turn one of them negative, that would be easy to eliminate the x's, okay? So that's what you have to ask yourself. Which one is easiest to eliminate? Then you would get those variables to be the same number with opposite signs. So again, the coefficient of my x's here were both 1s. Well, we did half of what step 2 told us to get them to be the same number, but we need to also get them to be exact opposites. That's why I multiplied by a -1. Okay, and then finally step 3 says add and solve for one variable and substitute it in to find the next. So again, a lot of stuff here, guys, but it's going to be very easy once we actually get practicing on this. Okay, so for 1 through 6, let's go ahead and go through the steps. First off, it says find out which variable would be easiest to eliminate. Well, let's look at our x's and let's look at our y's. So here's my x's. Here is my y's. Well, on my x's I have a 1x and a 3x. So if I were to add that, that'd be a 4x. So that wouldn't eliminate. But look at that 2y and the -2y. If I were to add that, wouldn't those two eliminate? They would, right? So why don't I go ahead and start by doing that right away? Let's add those up so I can eliminate my y's. This one's gonna be kind of nice because I'm not gonna have to multiply them by anything really. Okay, so let's go ahead and solve this one. So again, x plus 3x is a 4x. 2y minus 2y plus a -2y would cancel each other out, and then finally 5 plus 7 would be a 12. So I'm going to divide that by 4, divide that by 4. So I get x equals 3. Simple enough. This one is actually going to be kind of an easy problem. All right, the only thing I have to do now is substitute that 3 back into one of my original equations. I'm going to go ahead and do it to the top one. So this is going to be 3 plus 2y equals 5. Subtract the 3. We get 2y equals 2. Divided by 2, I get y equals 1. So my solution here is 3, 1. And remember, you can always double check, make sure that actually works by substituting this in for your x and this in for your y. Okay, let's go ahead and try out number 2. So, yet again, let's ask ourselves and actually look at both of these columns. Let's look at our x's and let's look at our y's. Well, for the x's, I have 1x and 2x. Again, why am I saying 1x? Well, because there's an understood 1 right there. Okay, so 1x plus 2x, if I were to add those would actually not eliminate because that would be a 3x. What about our y's? 1y plus a -3y, that would be a -2y, so those would not eliminate. Notice what I went through, guys. I went through the steps. Do any of those two eliminate right off the bat? Well, they don't. That means I'm going to have to multiply somewhere here. Okay, so the question is, what do I want to multiply by in order to eliminate? Okay, well, in order to figure that out, you have to ask yourself, which one do you want to eliminate? And there's no right or wrong answer here, guys, but I will give you guys my word of advice here. I would multiply and try to get rid of the variable that already has 1 plus and 1 negative. Okay, so let's notice again on my yellows, my x's, I have a +1 and a +2. Those are not opposite signs. But on my y's, I have a +1 and a -3. So if I wanted to get them to eliminate, I'd have to get a what? I'd have to get a +3 and a -3. Well, the good thing is I already have that -3. Well, what would I have to multiply the top to get it to be a +3? Well, I have to multiply the whole thing by 3. So let's see what happens when I do that. So what do I get? I get 3x plus 3y equals 1. And then in the bottom one, I didn't change it. I didn't multiply it by anything, so I'm just going to rewrite it. Now look at what happens when I add. Now my y's are going to cancel each other out, and I'm going to have 3x plus 2x, that's a 5x. And then I'm going to have, whoops, I multiplied wrong. right here. Forgot to put a 3. Okay, then I have 3 plus 12. That is going to be a 15 divided by 5. So I get x equals 3. So then I get 3 comma something. Well, let's find out what that other something is. By substituting it back into one of the equations, I'm going to go ahead and use this one. So that would be 3 plus y equals 1 minus 3 minus 3. We'd get y equals 2. And again, guys, I have my solution of 3 comma 2. But remember, that whole situation of which one you want to get rid of first, the x or the y's, that's your choice. If you wanted to get rid of the x's, okay, then you would have just had to find something to eliminate that 2x. Well, what is the exact opposite of 2x? Well, negative 2x. So what do I want to multiply this top one by, that 1x by, in order to get negative 2x? Well, 1x times negative 2 would have given me a negative 2x. So then you could have gone through that route and actually found out a similar answer. Okay, if you do want to verify that that would work, go ahead and pause the video and try out that method. Okay, I think for the sake of time, I'm going to actually not do that to make sure we get through a few more of these practice problems. But again, we're going to get a little bit more practice here, and we'll actually end up figuring out the easiest way to do these. Okay, number 3. So number 3, we're going to go ahead and read them off. So negative 2x minus 9y equals 30, and 5x minus 2y equals negative, I'm sorry, positive 23. Again, I always like to just kind of look at my x's and then look at my y's, and then why it deleted, I'm not sure. Okay, I don't know why it's doing that, but anyways, this is so annoying. Sorry about that, guys. I'm not sure at all why it's doing this. Okay. Sorry, I'm just doodling here trying to make sure that this pen still works. Alright. Okay, I have no idea what it's doing now. Alright, let's try to go back to this. Alrighty, so number 3. I'm going to look at my x's. I'm going to look at my y's. Well, let's look at the x's first. And hopefully my pen will start working the right way in a second. Okay, so negative 2x plus 5x. Well, if I add those, nothing's going to happen. Okay, it's not going to eliminate any of my x's. It's not going to do anything. Okay, I'm going to end up getting a 3x. That doesn't help us. What about if I add the negative 9y and the positive 2? I'm sorry, and the negative 2y? Well, again, that would give me a negative 11y. That wouldn't help me at all. So what I'm going to have to do is multiply something here. But be very careful. Remember, and this is another helpful hint, guys. Which one of these is smaller? Okay. Well, the 2, and forget about the negative for a second. But which one of those is smaller? The 2 is smaller, right? Is there anything I can multiply 2 by in order to get it to turn into a 5? Well, no, there isn't. Okay. So I'm going to forget about the x's for a second. But what about the y's? Again, which one is smaller, the 2 or the 9? Well, the 2 is smaller, but what can I multiply by 2? Or what can I multiply 2 by in order to get it to be a 9? Well, I can't. There's nothing I can multiply by. Okay? So what I'm going to need to do is actually multiply both top and bottom by something. Okay? So what you want to try to do is this. So my choice right now, again, it doesn't matter which one you try to eliminate, but I'm going to try to eliminate my x's. And I'll show you what I'm going to do. I'm going to write down my multiples of 2. Okay? Now I'm going to write some multiples of 5. do you see any multiples that match? Okay, and I hope you guys can see that this right here is a multiple that both 2 and 5 have in common. So you have to ask yourself, what do you multiply 2 by in order to get a 10? You have to multiply it by 5. I'll ask the same question for 5. What do you have to multiply 5 by to get 10? Well, you have to multiply it by 2. Let's see what happens when we do that. So again, we're going to distribute. We're going to get negative 10x minus 45y equals 150. Okay, now for my bottom, I'm going to also distribute. So I get positive 10x minus 4y equals 46. Now notice my x's right here. What's true about my x's now? They're the exact same number, they have the exact same coefficient, and they are exact opposites. So now I can add them and get a good result. So those will cancel out, and I get a negative 49y. Okay, 150 plus 46, that is a 196. If I divide both of these by negative 49, you guys might have to confirm this on your calculator for me, but I believe this is a negative 4. So my y value here is a negative 4. Again, guys, this will start to make a little bit more sense as we keep practicing, so don't give up, okay? So now I just need my x value. I'm going to go ahead and substitute that y into any of my two equations. I'm going to go ahead and just do the bottom one because it has less negatives. So I'm going to do 5 times, 5x minus 2 times negative 4 equals 23. So this is 5x plus 8 equals 23. Subtract 8. I get 5x equals 15 divided by 5. We get a final answer of x equals 3. So my ordered pair is 3, comma, negative 4. I am now done with that problem. Okay. All right. So I'm hoping this is starting to make a little bit more sense now, guys. But what I want you guys to do is try out number 4. Again, go through your process, guys. Which ones of these should I eliminate? Well, let's see. That 4x and the 3x, if I were to add them, they wouldn't eliminate. What about these? Would these eliminate? No. Okay, none of those would. But I do notice, and again, you have the freedom to choose whichever you want, but I noticed right away in my y's that I already have one negative symbol and one positive symbol. So now I just have to figure out what I have to multiply them by in order to get them to be the same number. Well, can I multiply? Let's look at the smaller number, which is 2. Can I multiply 2 by anything to get it to be a 3? No. Okay. So that means we're going to have to find a multiple of both 2 and 3 that I can multiply by in order to get the same number. So again, let me list a few multiples of 2. And let me list a few multiples of 3. And can you guys already spot which one I'm probably going to use? Hope you guys already spotted. That's 6. So the question is, since I'm going to have to multiply both of them, what do I have to multiply this negative 3y by in order to get a negative 6y? I got to multiply it by 2. What about in the bottom? What do I got to multiply the 2y by in order to get a positive 6y? Well, I have to multiply it by 3. All right, guys. I gave you guys some huge hints here, so what I want you guys to do is to pause the video and try this out on your own. All right, let's go ahead and take a quick look at these. So if I distribute that 2 in here, I'm going to have 8x minus 6y equals 22. In the bottom, I'm going to get 9x plus 6y equals negative 39. If I add these columns now, we'll notice that my y's will cancel, so I'll get 17 x equals a negative, what is this? A negative 17. Okay. I want to get rid of that 17 in front of my x. So I get a final answer here for my x of negative 1. Once I have that, I can go back into substituting that into one of my equations. I'm going to go ahead and use the bottom one since it has more positives. Okay, that was my original, but now I know my x, so I'm going to go ahead and substitute that in there. It would be a negative 3 plus 2y is 13. I'm going to add 3 to get 2y equals negative 10 divided by 2 divided by 2 for a final answer of y equals negative 5. All right. So after completing that, guys, you should have gotten y equals negative 5 and x equals negative 2 for a final answer of your ordered pair negative 1, negative 5. All right. So number 5. This is a prime example of why I always like to check both columns. Okay, that 2x and 4x, well, if I were to add them, that would be a 6x. So no good there. But what about the y's? That's a positive 3y and a negative 3y, and look at that. If I were to add them already, those would cancel out. So let's go ahead and just go straight to it. So this would be 6x equals 24. I get x equals 4. Probably one of the easiest elimination problems you can find. Okay, so now I have my x equals 4. So into this original equation, which was 4x plus 3y equals 16, I'm going to substitute that in there. I'm going to get 16 plus 3y equals 16. Subtract 16. Whoops. Okay, subtract 16. So I get 3y equals 0. Well, I still need to get rid of that 3, so I got to divide by 3. And we know that 0 divided by any number is just 0. So my final order pair is 3, 0. All right, great job. So again, number 6. Let's go through our process, guys. Let's go through our frame of thought. Can I add those two to eliminate? No. Can I add these two to eliminate? No. So now what's the next thing that I always ask myself? Well, I always ask myself is, are any of those two, either my x or my y, already a plus and a minus? Okay. Well, I notice on my y's I already have a plus and a minus. Yeah, they're different numbers, but now we just have to find a multiple of that goes into both of them. Okay. So I have a plus and a minus, so I'm going to try to eliminate the y's. Okay. So let's ask ourselves, from those two numbers, the 5 and the 6, which one's smaller? The 5 is. So can I multiply 5 by anything to get 6? Well, no, I can't. So that means, again, I'm going to have a situation where I'll have to multiply both top and bottom. So I need to find a multiple of both 5 and 6. Okay? And I'm sure now you guys are getting used to this, so you don't have to write this each time. I just like to write it to make sure everybody understands it. Anybody who's watching these videos understands where I'm getting these numbers from. But I'm sure you guys have already spotted it. The common multiple here is 30. So you have to ask yourself now, what do I multiply the top part to get, or what do I multiply this top equation by so that 6 times something is 30? Well, that would be a 5. Same thing on the bottom. What times negative 5 equals a negative 30? That would be a positive 6. So let's distribute. That would be 145, if I'm not mistaken. then that would be negative 24x minus 30y equals 150. Okay, let's add that all up. These eliminate, so I get a negative 59x equals a positive 295. All right, and if I am not mistaken, you can divide both of those by negative 59 to get x equals a negative, whoops, I'm sorry, not a negative 6. I believe that is a negative 5. If I could erase that. Okay, it's not letting me erase it, so I'm just going to go ahead and rewrite it on the side. That would be x equals negative 5. My last step is to just figure out what my y is. So I'm going to go ahead and substitute that in. I'm going to go ahead and use this top equation. Okay, so that would be negative 7 times negative 5 plus 6y is 29. That'd be a 35 equals 6y 9. Subtract my 35. So I get 6y equals a negative 6. Final step, divide by 6, divide by 6. So I get y equals negative 1. So my final ordered pair, negative 5, comma, negative 1. All right, so that is elimination, guys. Okay, so just remember, can I add any of the x's or the y's to already cancel one of them? Okay, if you can do that, then my personal opinion and what I think is easiest is to look for the ones, either the x's or the y's, that already have one positive symbol and one negative symbol. Once you do that, try to see if you can multiply something by the smaller number to get it to be the exact opposite of the top number. And if that final step doesn't work, then what you're going to have to do is find a multiple of both of those numbers that you can multiply both equations by. I know that sounds like a lot, guys, but I know that once you try out a few problems, you guys will start to understand exactly what that means. Okay, so what I'm going to go ahead and have you guys do is try out number, let's see, I feel like number 7 and number 8 are very similar. So what I'm going to have you guys do is just try out number 7. We're going to go ahead and skip number 8 for a second. And then what I want you guys to do is also try out number 9. Okay? All right, so let's go ahead and try number 7 first. So go ahead and try out number 7 and number 9 for me, please. So go ahead and pause the video right now, and then we will come back to verify that you guys have correct answers. All right, so let's go ahead and take a look at 7 and 9. So number 7, we're talking about substitution. Remember what we asked ourselves in substitution is which of the equations already has a variable solved for it. So in this case, we know that y equals x plus 6. So why can't I just substitute that in there, which is exactly what I'm going to do. So I really have negative 5x minus, let's put it in parentheses, x plus 6 equals 0. And then remember, because there's really a negative 1 here, I have to distribute it to both of those. So what do I get? I get a negative 5x minus 1x minus 6 equals 0. Okay, well, let's see. Those two are like terms, so that's a negative 6x minus 6 equals 0. I want to get the x by itself, so why don't I get rid of that 6 by putting it, or rather tossing it to the other side. This is a negative 6x equals 6. I can now divide by negative 6 to get x equals negative 1. So that is part of my solution. Let's now go ahead and find y. So I'm going to go ahead and use this top equation. which was y equals x plus 6, but instead of an x, now I'm going to use a negative 1. So this would give me y equals 5 for a final answer of negative 1 comma 5. So I sincerely hope you guys got a similar answer. And if you did, great job. If you didn't, make sure you go back to the section on substitution and go ahead and practice using some of those examples. Okay, and just to kind of wrap up with elimination, why don't we go ahead and try out number 9? Okay, so again, if it helps, use highlighters or just kind of think to yourself in your head, can I add at either of those two columns to eliminate one of my variables? Well, 8x plus 6x, that would just be a 14x. So no. How about the 4y and the 2y? Can I add those? Well, no, that would be a 6y. Okay, so next thing on our list. Can I multiply, or rather, do I have any of those with opposite symbols? Well, the 8x and the 6x are both positive, so no. And actually, not even on the y's either, because I have a positive 4 and a positive 2. So nothing here, okay? Now I want to ask myself, okay, is there any way I can multiply the smaller number of the two to get it to be the bigger number? So can I multiply 6 times anything to make it turn into an 8? No, I can't do that. Okay. How about that 2y and the 4y? Can I multiply 2 by anything to get it to turn into a 4? Well, yeah, I can. 2 times 2 would be 4. But remember, what do we ultimately want to do here? We want to get them to eliminate, so I'm not going to multiply it by a positive 2. I'm going to multiply this by a negative 2. And let's see what we get now. So again, I'm going to rewrite my top equation because I didn't do anything with that one. But now on my bottom equation, I'm going to get negative 12x minus 4y equals a negative 28. Let's add them down now. Let's see if I can get my eraser to work. Well, let me try this. There we go. Okay, so this is a negative 4x. These two eliminated, and this is a negative 20. Divide both sides by negative 4. We get x equals a positive 5. That is part of my solution. So now let's go ahead and try getting my y here. So I can use any of the equations. I'm going to go ahead and use the top one. So 8 times 5 plus 4y equals 8. That's 40 plus 4y equals 8. Subtract my 40. Subtract my 40. I get 4y equals negative 32. For a final answer of y equals negative 8. So my final ordered pair solution is 5 comma negative 8. All right. So I think we are in good shape here. I think just since we do have a little bit more time in this video, I want to try to cut it off around 41 minutes. I think we can do elimination for number 10 real quick. So let's go ahead and go through that one, but otherwise I think we are in good shape. So let's go ahead and take a quick look at that last one, and then we will end the video there. So let's ask ourselves the important questions again. Can I add these two to cancel them? No. Can I add these two to cancel them? No. Now I ask myself, do any of those already have opposite signs? Well, negative 3 and negative 4, nope, those are both opposites. Now, a positive 1 and a negative 4, well, yeah, those are opposites. Now I just have to turn that 1 into the opposite of a negative 4, which would be a positive 4. So I'm going to have to multiply the top equation by 4. So what do I get? I get 4, I'm sorry, not 4. I'm going to get negative 12x plus 4y equals negative 64. And then I'm going to get a negative 4x since that one didn't change. Basically just rewriting it. But now I can add both columns. These will cancel. I get negative 60x equals a negative 80, I believe. Okay. Last little bit here is to divide by negative 16. Well, we know that would give us a positive 5. Let's just now find our y, and that will be our last thing for this video. I can use whichever one I want, so I'm going to go ahead and use the top one. So negative 3 times 5 plus y equals negative 16. That is a negative 15 plus y equals negative 16. Add 15 to both sides. We get y equals negative 1. So my final answer here is 5, comma, negative 1. And just like that, I'm ending right where I wanted to at 41 minutes. Okay? So, again, guys, thank you for listening, and I hope this started to make a little bit more sense now. Remember, you guys have 3 methods now of solving linear systems of equations. So use whichever one you think is appropriate depending on the scenario. Okay, guys? I will talk to you guys soon. Easy. Bye.